Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Embedded Computing Design. This week, my guest is Rolf SEGGER, who you probably know. He's the founder of SEGGER. I was going to make a joke about, I hope he didn't spend a lot of money on marketing for the name of the company, but I'll just pass on that. Um, in our pre-call, I have to let the audience know that one of the things we talked about was that one thing that you and I have in common is that we tend to always tell the truth. For better or worse, we tell the truth. So that never comes back to bite you. So I'm going to hold you to that, Rolf. Okay?
Absolutely, absolutely, and
Okay.
I like the marketing thing. I never looked at it that way. That it's an inexpensive way to name the company. Didn't spend much on the marketing, but it turns out. I mean, I'm fortunate. Segger is actually a pretty good name in a sense that people can remember it. Everybody can pronounce it. It's a good name, so I don't regret it.
Well, you didn't consider Rolf microcontroller?
I don't think, I mean, I'm personally, it's a different story. I'm not very happy with my first name. I mean, it could be worse, but Rolf, a lot of people have a hard time pronouncing it. So when I go to a Starbucks, for example, they're asking for the name they put on the cup. I usually say Mike, but Mike microcontrollers doesn't sound good. Sega is pretty good. I'm quite happy. Besides, now it's a little late to change it.
I agree. I totally agree. And it is certainly well known in the industry, as are you. So I'm very pleased that you took some time out of your busy schedule to join me. The topic that I want to talk to you about is something that it seems as if Sega has developed internally, but could very well be used industry wide. And I believe it's something you call MApps, which is short for embedded apps. Do I have this right?
You have that absolutely right. Spot on. You want me
Okay,
to
so
talk a
what
little
is
bit
that
about it?
exactly?
Um, it's basically the ability or a piece of software that allows an embedded system, technically not just an embedded system, you can run it on a PC, but anything that runs on the embedded system, you can basically run on a PC as well. It's just a bigger system. But it's designed for embedded systems and it allows embedded systems to run apps. And if you think apps we don't need apps in what I'm doing, I think you need to reconsider that because MApps is extremely small. So footprint is just 3-4 kilobytes of flash memory on the target and basically no RAM usage. And it allows you to download apps to to give apps to your embedded application, whether you download them via USB, Ethernet, whichever way, or put them on there via SD card or whatever means you have is basically irrelevant. You can extend the functionality of your embedded device in a safe way using MApps.
When you say apps applications, what are you referring to? What sort of functions would this be?
It's completely up to you, the firmware designer. So,
Well, give me an
uh,
example.
well, one simple example that as you mentioned before, we use it internally. So we use it for our Flasher in system programmers, industry leading top speed guarantee and everything. But the problem there was initially we started with a Flasher and it was able to program a couple of microcontrollers, a handful. And then you add another one, you add another one, you add another one. And every time you do that, you recompile the firmware. And it's not great to distribute new firmwares all the time, but it's also not great because it bloats the firmware, it inflates the
Hmm.
firmware. So we moved to a system where the flash loaders could actually be downloaded in RAM and executed in RAM. So that is how that started. We use it for a lot of other things, for example, J-Link as well. You know, in J-Link, you have a similar challenge. You have chips that need a particular sequence, say after reset, that is very much different from one chip to the next. And you have a very short time window, say 200 microseconds. And the 200 microseconds isn't enough to do it on the PC because your USB latencies are too long. So it needs to be done in the probe. Same thing, you have various different chips and you don't want to recompile the firmware every time. So same thing, we can download an app that handles that, the time critical part. But it's also other things. It's good for us, but it's also good because we can give this type of program this ability to the customer. We can give the customer basically an SDK. The customer asked me, are you going to add support for the so-and-so chip if we ever need it? I will say yes, and we're absolutely willing to do that, but you have to be aware that we have limited resources. So I can't guarantee that we can't drop everything if you need a new chip. But I don't want you to depend on SEGGER. You can always do it yourself. You can take the SDK and write the flash loader yourself. And the nice thing is, I mean, it's all sandbox. So even if somebody who's not a world's greatest programmer screws up and accesses illegal memory, somehow screws up, it's no problem because it's all sandbox. The application simply stops executing, and that's it. So you can even give the ability to extend the functionality to your customers.
We did a podcast not too long ago that on a subject that I think you're alluding to. And one of the issues with embedded devices is that they may be in the field for decades, and that's not unusual. But you have to keep updating them to make sure that you have the latest uh, security on them, which is ultra important. However, one of the problems that we're starting to run into is that there isn't enough space to update to the latest because we just run out of memory on these things. Does this solve that problem?
Yes, in a way, I think it does because um, different different customers have different needs, and the app basically means you can put on whatever your specific needs are. It's very similar to what you have on your phone, right? On the phone, it has a certain basic functionality like phone, email, and but then you add apps to it, and whatever it's the apps are basically what your specific needs are. So it could be a navigation system, could be TikTok, WhatsApp, and whatnot. There's like thousands of apps out there, maybe 10,000s, but you only download the ones that you need.
Mm.
So instead of putting everything on your phone, you put on your phone what you need. There's a similar thing with the with MApps. You can basically you add what you need. So it does help to keep it small. I mean, in the example of the flasher, if we support, I think we're somewhere like 30,000 devices. We have thousands of different flash loaders. If you just assume one flash loader is a kilobyte and you have thousands, you have 5,000 of them, you're already at 5 MB, right? If you just download what you need, that is not a problem. If you add them all to the firmware, it makes the firmware very big and potentially too big for the amount of memory you have, especially as the thing grows. So yeah, it does. It definitely contributes to solving that problem.
This does sound like something that should be industry wide. Are you doing something to help push it through the industry, or will this remain a SEGGER thing?
Well, it's a good question. I do things like that. We do press releases, we have the compiler online, and I do podcasts like this one to make people aware of it. So, as an
Will
industry
you go through a
standard,
standards body to put it out there to make it, I don't know if generic is the right word, but to make it so it's not a SEGGER product?
well, I mean, at Sega, we still need to make money somehow, right? But I wouldn't mind making some of it or all of it a standard, making it openly available. I'm open to the idea. Just our connections to the standards bodies aren't that good. But I'm open to the idea. It does sound like a good idea.
Yeah, I would definitely agree with that. And frankly, between you and me and the people listening, I don't know if I'd go through the standards bodies either. I think just putting it out there and making it open is the right way to go.
You're probably right. So let me think about it.
Okay. So what would somebody have to do today if they wanted to use this?
Um,
Is product the right word? Is it a product?
Yeah, product is the right word. It's basically a piece of software that they would have to get slash license from us to try it out. It's easy. You can just go to the Sega website, you can download it, you can run it on the PC. I mean, as I said, you can execute the same apps on the PC if you have the
Mhm.
same API, so sandbox execution there. You can try it out there. The compiler is available online, but if they want to use it in a product, they would have to get it and license it from us.
Yeah, that's sort of what I was thinking. So you have the hooks built in to do compiling, debugging, and all that stuff, and you make it. I assume you're making it very easy for somebody who wants to do that.
That's exactly the idea. We also have a source code, a project available, so it is really easy to do, and it shouldn't take for an experienced developer, it shouldn't take more than half a day to add this functionality to existing software.
And how do I make sure that it's secure? Because I'm uploading my apps to SEGGER now, right?
No, 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 no. You're not uploading your apps to Sega. How you distribute your apps is entirely up to you. So, for example, on the Flasher, the way you put an app on there is you can run it in mass storage device mode. So you basically press the button and it acts like a USB stick. So you can put it on like this, or you can put it on via USB. It has the apps have nothing to do with SEGGER. You're independent of SEGGER. So
Okay.
how you deploy the apps is entirely through you, and Sega doesn't have Sega just provides the software, and then what you do with the apps, what functionality your apps you make available to your apps, and how you just deploy the apps, entirely up to you.
Okay. So what can somebody expect to see in MApps 2.0?
Good question. MApps 2.0, we're just about to release it, and we're adding a native code generator. So apps, if you will, if I say they have a problem, it's exaggerated. They're really small. Well, there's one downside to apps is the execution is not as fast as a native code, right? So they basically get interpreted. So we look at the opcode and then do whatever that opcode says. And, the virtual processor is a 16-bit processor. It's similar to an ARM or RISC-V or RISC-V, I should say. We just started from scratch and gave it a really good, efficient instruction set. In any case, it gets interpreted, and the speed is less than that of the target system. We have two different interpreters. One is C code, so highly portable, runs on anything, and we have an ARM optimized version. The ARM optimized version, you get to about factor 30, 40 that you're slower than the native system. That sounds, at first glance, it sounds really slow, but it isn't really that slow because for most operations, it's good enough. And anything that's really time consuming, you can always put in the firmware. For example, on the flasher, we have things like memcopy or compute CRC in the firmware. So the time critical stuff you can put in the firmware. However, faster is always better. And what we've done is we've came up with this native code generator. So it translates the application code for the virtual processor. We call it the S32. S, as you may have guessed, stands for SEGGER. So the S32 CPU, we translate those into native code for ARM, for a Thumb 2 processor. We could also do a native code converter, code generator for other processors like RISC-V, but currently we have it for the most common platform, which is that we also use, which is ARM Thumb 2. And we achieve an amazing like 30% of the native speed. So you run a dry stone on this thing. I can download a dry stone, and it achieves about 30% of the native speed of what the ARM controller can do if I compile it on a high-end ARM compiler directly. And that's pretty amazing. And the 30% includes sandbox checking, right? If you compile a program on the ARM, there's no sandbox checking. You have to use an MMU or an MPU to make sure there's no memory access violation if you wanted to monitor that. With MApps, it can all be done in software, and we still achieve 30%. I think it's pretty amazing. So that's what's new in 2.0, and I think it's absolutely ready for the world.
That's great stuff. I want to ask you something. I want to change gears completely, and if you don't want to do this, we can cut this part out. But you sit in a great position to answer this. In a year or two, will we even need programmers because of AI?
That's a difficult question, right? How do one smart person say predictions are hard, especially when they concern the future, right? And especially and AI hasn't made it any easier. I find the trend um, of change, the speed of change in our world has definitely accelerated. So when I was 10 or so, we had a telephone had a rotary dial, right? And then how things have been progressing, but not that fast. But the changes we've seen lately are changes accelerating, and AI is going to accelerate it even more. And I think the same thing is happening in for programmers that we see, say, in the legal field. You no longer need like the juniors, right? You need the seniors. You need the seniors to feed the AI, and you need the seniors to verify what the AI does is the right thing. So, will some people lose their jobs in programming? I think so, long term. Yes, probably yes. But
Very good.
how
Well,
badly the effect is hard to say. The good thing in the embedded field is that at least you need people to verify it on through hardware. So because it's hardware related, anything that runs completely on a host, I think people can do, AI can do almost itself, test it itself. Anything that is connected to an embedded system to the real world is harder to replace. But yes, a lot of people will lose their job down the road. It's a tough question. Like, what do you want to focus on if you are like 18, 19 right now? What is still going to be needed? I mean, I have a couple of examples, but I think that's too much for this podcast.
yeah, we actually had a discussion a little while ago with somebody who runs an engineering department in an electrical engineering department in a very prominent U.S. university, and we asked him if if the jobs he's preparing these seniors for are going to be there, and he said, "I don't know." So it's a little scary, and I'm certainly glad I'm not in that position.
I agree, it's a bit scary, but I think for the people who are really good and motivated, they don't have to worry. It's the people in the middle, like the people that
Hmm.
basically say, "Yeah, I don't want to, Mr. Sega, I'd like to work for you, but as little as possible. I would not like to work on Fridays."
Hey,
So
if that
those
opening is
people.
there, you let me know because I'm a taker. Very good. Well, thank you, Rolf. I certainly appreciate you taking the time. And as we started this, we have been telling the truth, and that is very much appreciated.
Yeah, I try my best. I try to always be authentic and tell the truth. So
Absolutely. That was Rolf Segger. He is the founder of Segger Microcontroller, and I am Rich Nass with Embedded Computing Design.
thank you, Rich. I enjoyed our talk. Have a good one.